So the next topic we're going to be discussing here is some of the core layer 2 switching features of the Nexus, both for the 5000 and for the 7000. Now, I'm not going to spend a lot of time talking about just core layer 2 switching that is the same type of features that you would see on regular Catalyst iOS or other layer 2 switching platforms. So we're not going to get into a lot of the details of like what are VLANs, what is trunking, what is VTP, that type of stuff, what is spanning tree. We're mainly going to be focusing on some of the comparisons versus how Nexus NXOS works differently than regular Catalyst iOS, and some of the behavioral differences, and then some of the configuration differences that we need to be aware of. So as an overall view of the platform, now we talked about this a little bit yesterday, where the Nexus 7000 and even the 5000, it is both a layer 2 switching and a layer 3 switching platform, but really at its core, its main functionality is based on layer 2 networking. So we'll see that there are layer 3 features we're going to be talking about, like OSPF routing, eIRB routing. OTV is a layer 3 feature because we're routing basically routing layer 2 over layer 3. But the vast majority of functionality is really meant to be based on its layer 2 switching. Okay, so we're going to see that a lot of the aspects are very similar to how regular Catalyst iOS works, but there's going to be some key caveats that we need to take a look at the differences in. So some of the main similarities, we have things like VLANs, trunking, VTP. Spanning tree we supported only in rapid per VLAN spanning tree and in multiple spanning tree. So there is no legacy regular 802.1d support like you would have on the regular Catalyst iOS platforms, which is fine though, because both rapid per VLAN spanning tree and a multiple spanning tree are backwards compatible with the original legacy spanning tree. And honestly, they really have no place in today's data center environments, where we would not want spanning tree to force us to be subject to listening and learning delays, to convergence times of 30, 45 seconds or more based on failures in the topology. So a lot of the features that we're going to be dealing with are mainly based on high availability, both from a convergence point of view in the data center and from the amount of forwarding capabilities that we have in the network. So instead of using legacy spanning tree and saying I have one port that's my root port and I can actively forward over that, and then I have these alternate links that are blocking, in a data center environment, ideally we don't want to have that. We want to be able to forward over all the possible links, and that's where a lot of these enhanced features are going to come in. Things like virtual port channels, fabric path, possibly OTV for doing the layer 3 tunneling, to make sure that we really are not subject to some of these legacy type problems in other traditional enterprise networks. Now beyond that, there are going to be some additional key new features that are specific to NXOS. Okay, one of them that we saw yesterday was the fabric extenders, or the FEX, which again is basically a remote line card of the parent switch of either the 5000 or the 7000 series Nexus, where it doesn't have a separate management plane, doesn't have a console port, doesn't have VTY ports. We basically just plug it in physically to the parent switch, tell the parent switch where the FEX is physically located on its ports. It's going to boot up, download the NXOS image, then it's going to appear as just regular ports that we can configure on the parent switch. The next one we have is virtual port channels. We're going to be spending a significant amount of time in this class talking about that starting today. We'll see whether it may take us longer than today to go through VPC, because from a very high-level overview, it does seem like a fairly simple feature, but once you start to get into the nitty-gritty details about the different failure scenarios, the different ways that load balancing occurs, how do we deal with unknown frames, how do we deal with multicast, how do we deal with orphan ports when there's different types of single connect devices to the topology. So we want to make sure that we can go through really all the variations at an expert level for this particular feature. Then later in class, we're going to talk about fabric path, which is basically a replacement for spanning tree, so that we are doing layer 2 routing as opposed to layer 2 switching. And then, as I mentioned, OTV, overlay transport virtualization. That's going to allow us to basically bridge our layer 2 traffic over a layer 3 data center interconnect, or basically a layer 2 tunnel over IP. Now, one of the first things that we probably want to know about Nexus and its behavior as compared to Catalyst iOS are what are some of just the default options that we have on the command line when we actually get onto the box. So there's a couple that are notable here. First is going to be the default port modes that the links are running in. And this is going to be dependent on whether we're dealing with Nexus 5K or 7K, and in the case of 7K, whether we're dealing with the M1 or M2 cards or whether we're dealing with the F1 or F2 cards, because based on the physical line cards, we have different capabilities that we can or cannot run. We're also going to have this introduction of the spanning tree port types, which is going to simplify some of the features that in regular Catalyst iOS would normally have individual commands to enable. Things like spanning tree port fast or VTP pruning. Some of the functionality of these features have kind of been rolled into a more straightforward syntax interface, which is going to be related to the port types in spanning tree. We then have an additional feature that is also available on the 6500, but most of the lower level platforms don't yet have this, which is known as spanning tree bridge assurance, which is going to be used for a couple different reasons. We'll see why. One of them is going to be for preventing unidirectional links in the network, where if I have a multi-mode fiber, let's say, that has a send channel and a receive channel, I want to know that if my send channel is working, but there's some layer 1 cabling problem in the data center and receive channel is not working, I need to make sure to disable that link and then not include it as part of the layer 2 forwarding path. But we'll see there are some other functionalities of bridge assurance and why you would want to run it. It's actually one of the features that are enabled by default in Nexus, both in the 5K and the 7K. And then we have something that's known as the port profiles, where port profiles are going to be similar to the switch templates, or excuse me, the smart port macros in Catalyst iOS. But it's going to be mainly for manageability, but it's going to be a little bit easier to use than the macros that we have in regular Catalyst. So going back then to the first topic here, we have the default port modes. First thing that is notable is that all of the links are shut down on the platform by default. And this can be a little bit confusing at first, but from a design point of view, this makes sense because you would not want basically unknown links in the data center to be provisioned unless you specifically added it to your workflow, like in your diagrams and your change control. You wouldn't want someone doing a physical layer 1 miscabling and then changing the forwarding pattern of the data center layer 2 network. So if we take a look here on the command line on one of the 5Ks, and we just look at the show interface status or the show interface brief, both of these are going to be used to give us some information about the layer 1 and layer 2 status of the links. The show interface status here, this is going to tell us, like, is the link plugged in? What's the VLAN? What's the speed and duplex? What's the type of cabling? Which in this case are the copper twin-X cables that we're using. These are 10 gig SFP plus cables. But if we take a look at this on the 7K and look at the show interface status or the show interface brief, we see that there's some behavioral differences on the default port modes between the two platforms. Where on the 5K, these links are connected by default, so they're not in the administratively shutdown state. And they are layer 2 switch ports that you can see, like any other platform, they belong to VLAN 1. And they're using auto negotiation. You can see they're full duplex for 10 gig. But on the 7K, that's not the case. Some of the ports here that are coming from the first slot, which again is the M1 card, our layer 3 card, by default, these links are shut down and they're running in layer 3 routing mode. But what can be kind of confusing about this is that if we're actually to look at the running config, it doesn't actually tell us that there. So we see that these links, it looks like there's no configuration on them, but there actually is. On the first slot, we would normally see in Catalyst iOS no switch port and shutdown, but in the case of NXOS, it just looks like the default port mode. There's no config there. Then likewise for the F1 or the F2 ports, which are layer 2 only modules, since those are layer 2 only, those are going to be layer 2 switch ports, but likewise those are going to be in the shutdown state. So in 7K, it just means that when you're actually provisioning the links, you need to make sure to go in there and say no shutdown. On the 5K, they're going to be up by default. Okay, so again, the F1 ports, those are going to be layer 2 switch ports. The M ports, those are layer 3 routed interfaces. Now, there are some default commands that exist in global config. And just like in regular iOS, since these are going to be the default options, you're not actually going to see it in the output of show run. But there's actually two defaults that are in there, which are the no system default switch port and the system default switch port shutdown. Now, what these specifically mean, the first of which is that for our M module, so either M1 or M2, those links are not running as switch ports, or in other words, they're running as native layer 3 routed interfaces. The second option, system default switch port shutdown, means that for any link that is running in layer 2 mode, it is going to be administratively disabled or shut down by default. So there may be a case where quickly you want to enable all the interfaces or you want to revert them all from layer 3 mode back to layer 2 mode. So we can change some of these defaults. Where if we were to say the system default is switch port, this is then going to change the M module, so either M1 or M2, from layer 3 routed ports, which are the no switch ports, change them back to layer 2 switch ports, which means they're going to run in access mode. So if we were to go to the 7Ks command line and say here system default switch port, then we look at the change in the show interface status. We can see that the links are still shut down, but notice that they have now changed to layer 2 ports. Okay, actually a couple of these didn't change, Ethernet 1.5 and 1.6, and I'll explain in a second why that happened. But previously the M1 ports were layer 3. If we show interface status or show interface brief, we can see now that these ports are in access mode, or at least the majority of them. But they're still in the administratively down state. If we were then to say the second command, which is kind of an odd option here, no system default switch port shutdown, means that for all layer 2 switch ports that are currently in the shutdown state, we're going to put those in the admin up state. But what's a little bit odd about these changes, again, is that it doesn't actually apply anything on the individual link level. So when you look at the show run interface E11, show run interface E21, there's no options in there that say either switch port, no switch port, shutdown, no shutdown. It's just going to be based on these defaults. So you want to make sure always to remember these two commands, the show interface status and the show interface brief. So we always know what is the port mode first, and then is it in the up or down state. Okay, we can run into some problems with compatibilities once we start to configure things like Ether channel with port channels or the virtual port channel features. We'll see that if the member links of the port channel don't agree on all sorts of different parameters, they're not going to be able to channel together. So if one of my links is in the layer 3 routed mode and one of my links is in the layer 2 switch port mode, then they're not going to be compatible and I'm not going to be able to form the channel. And for those of you that are familiar with port channeling in regular Catalyst iOS, you do run into some strange order of operations issues with Nexus that if your channel didn't properly form in the first place, you have a very difficult time to try to roll back the config to where you're undoing it and then to reapply the config in the proper order. So you really need to be aware of what's the proper order for the commands and make sure that when we're trying to form the channel that it's going to work correctly the first time. So if we look back at the command line here, the only other change that I made, again, was the system default switch port. I'm also going to say here, no system default switch port shutdown. And if we now look at the output of the show interface brief or the show interface status, we can see now that some of these links have come to the admin up state. Some of the links are still disabled. Some of them likewise are still in routed mode. And the reason why is that these two commands will only apply if no other changes have already been made on the link levels. So if I had previously gone to the interface and said something like change the speed or change the access VLAN, change it to trunking mode, basically any possible change on the interface, it means that these global commands are no longer going to apply on those links. Okay, if we take a look at the running config and look at interfaces E1, 5 to 6, we can see the reason why those commands did not apply was because they manually had the no switch port command configured under the link. which again is kind of strange though, because if we fall back to the previous default, which is actually the system default switch port shutdown and the no system default switch port, then we show interface brief. We can see now the first module, the E1/1 to E1/8, all of these are routed interfaces in the disabled state. But if we now show run interface E1/1 to 8, we'll see that at least previously, it's probably undoing it now, but previously we had the no switch port command on there. So this is from yesterday when we were making changes on associating the 7K to the FEX. Even though it didn't look like there was config on there, I actually had made a change, so it's not applying to this default command. So for simplicity, I'm going to change all of these to the layer 2 switch port mode. We're going to say system default switch port, but I'm actually going to leave all the links in the administratively down state automatically. So then when we actually start to build our topology and look at the different ports that we have to configure, we want to make sure that it's actually following along with what's going on in the diagram. Now, a couple other minor things about these ports. Normally in regular Catalyst iOS, most platforms are going to have the interfaces running in a dynamic state by default, where we have the dynamic trunking protocol, DTP, that for our layer 2 switch ports is going to try to negotiate either an ISL or a .1Q trunk, or worst case scenario, it's going to fall back to an access port. In Nexus, we don't have that type of port mode. We have either static access, static trunk, or some other modes that we'll talk about, like the FEX fabric, the fabric path, and a couple other minor ones. Okay, additionally, when we're dealing with the trunking, we only have support for .1Q. So there is no ISL support. Since it's a proprietary encapsulation, you'll see a lot of times there, for data center interoperability, most implementations will not use proprietary protocols. So for things like port channeling, for example, we don't have PAGP, the port aggregation protocol. We just have LACP, the link aggregation control protocol, which is the open standard, the 802.3 AD version. Now, next thing we need to know is how does spanning tree work a little bit differently on Nexus than it does in Catalyst. So by default, as I mentioned, we're going to be running rapid per VLAN spanning tree, which is still the Cisco proprietary version of spanning tree, but it is running rapid spanning tree, or RSTP, on a per VLAN basis. So this means that if we create VLANs 1 to 100 in the VLAN database, it means that we're going to have 100 separate instances of spanning tree. Now, whether we actually want that or not, whether we want the extra load on the control plane, we will have the option to configure multiple spanning tree, or MST, in order to try to cut down the number of instances that we have actually running for STP. Now, for the different types of spanning tree ports, this is a little bit different in Nexus than it is in the other platforms. There's 3 different types of STP port definitions that we have. We have the spanning tree port type normal, spanning tree port type edge, and spanning tree port type network. Now, all ports that are layer 2, whether they are on M1, F1, M2, F2, or the 5500 ports, those are going to be running as spanning tree port type normal. So essentially, they're going to be running in the same type of mode as a Catalyst iOS layer 2 switch port would work. So that's going to be the default spanning tree port type. Now, the spanning tree port type edge, this is going to be the equivalent of the STP port fast ports in Catalyst iOS. Now, since we're not running the legacy spanning tree, we don't have the Cisco proprietary enhancements, things like port fast and uplink fast, backbone fast, those type of options. Most of those are now built into equivalent type of functionality in the standardized protocols. So the equivalent of the spanning tree port fast command is now the spanning tree port type edge. Now, for the FEX ports, the Nexus 2000 that are going down to the end hosts, we take a look at here on the diagram, like any port that would be going down to our end servers or whatever devices that we have hanging off of the FEX. By default, these ports are going to be running as edge ports. Okay, and additionally, as I mentioned yesterday, these ports are also going to be running the BPDU guard feature, which means that if we detect a device running spanning tree that is sending BPDUs into those ports, the FEX is automatically going to disable it. or technically the parent switch is going to disable it because that's the one, the device that is doing the management. Now, the new definition that we have here then is the spanning tree port type network. Now, the spanning tree port type network is going to be running a feature that is known as bridge assurance. And as I mentioned, bridge assurance is on the Catalyst 6500, but most of the lower level platforms don't have this. And what the feature is designed to do is to prevent layer 1 loops in the network, where we have unidirectional links and there ends up to be a problem where traffic is being sent in both directions and spanning tree is having a failure. But it's also going to have some secondary behaviors that's going to be similar to what we would normally do with VTP pruning in Catalyst iOS. So with bridge assurance, these are going to be running on the spanning tree network port types. Now, the idea of this feature is that all of the network ports are going to be sending BPDUs, which is the spanning tree bridge protocol data unit, regardless of what their port state is. So whether they're in designated route, if they're backup ports, they're still going to be sending BPDUs, which is different than the original legacy spanning tree that said only the designated ports on the root bridge were the ones that were generating BPDUs. Then these BPDUs would flow downstream from the root bridge, from designated ports down to the downstream neighbor's root port, down to the designated port, and so on and so forth as it's exchanged throughout the entire tree. Now, what the effect of this then is, if we are sending BPDUs bidirectionally on every link, is that the BPDU basically becomes a layer 2 bidirectional keep alive, which is going to take over the functionality previously that we defined as loop guard in spanning tree. So ideally, bridge assurance would be used on any layer 2 interconnections between switching devices in the topology. So if we take a look at our physical diagram here, any type of layer 2 interconnections that we have between the 7Ks, any type of layer 2 interconnections between the 5Ks, we would want to make sure that these ports are running as spanning tree port type network, which means that for every VLAN that they have a spanning tree instance for, because remember we're running rapid per VLAN spanning tree by default, that we are going to be sending BPDUs out that interface. So the result is that we're sending BPDUs out. If we do not receive BPDUs in, then we are going to say that for that individual instance of spanning tree, or basically for that VLAN, the port becomes inconsistent for bridge assurance, and then we stop forwarding traffic. Now, there's actually two results of this functionality. The first is that we're preventing preventing loops when there is a unidirectional link in the network. So where I'm able to send traffic, but I'm not able to receive traffic back in. But the secondary functionality of this is that we have the same functional effect as if we were running VTP pruning in the network. Now, VTP pruning originally with the VLAN trunking protocol, the idea of this is that we had basically a management protocol, VTP, that was used on all the switches to advertise what are the different VLAN numbers that we're going to be allocating in the network. Now, once we create the VLANs, the secondary result of that means that we are also creating the spanning tree instances. So if I were to go to my VTP server and say I have VLANs 10 to 20, it means that I'm generating spanning tree instances or starting spanning tree instances for each of those VLANs. So it means that on the interconnections between the switches, like our layer 2 trunk links between them, it means that we are actively forwarding for that particular MAC address table, for the VLAN, those unknown frames, for unicast, the unknown multicast frames, any of the broadcast frames. It means that the flooding domain and the failure domain for the VLAN is much larger, just by allocating the VLAN numbers with VTP everywhere. So then at VTP, they came out with a way to kind of make this a little bit more efficient with VTP pruning that says the switches are going to actively tell each other, you know I have VLANs 10 to 20, but which ones am I actually using? If I'm only using VLANs 10, 11, and 12, then those are the ones that I only actively need to receive on the trunk links. Now, in the case of spanning tree bridge assurance, we basically have that same effect. That since the idea is that we are bidirectionally sending spanning tree BPDUs for every VLAN, and for any VLAN that we do not receive a BPDU in, we are going to put the port in an inconsistent state for that VLAN. It essentially means that the layer 2 network automatically prunes the VLANs off of portions of the network that it does not need. So if we were to try to visualize this here in the diagram, let's assume that right now the network is entirely just layer 2, so it's a flat layer 2 network everywhere. And let's say that we have a couple different end hosts. We have maybe the servers down here that are attached to one of the fabric extenders. Let's say that these guys are in VLAN 10. This FEX here is physically over here, so we have VLAN 10 on this segment. And maybe router 2 and router 3, they're also in the same VLAN, so we have VLAN 20. Okay, this means that from the fabric extender up to its parent switch, we want to make sure that VLAN 20 is forwarding, and then across whatever the rest of the layer 2 network is, whether we're going this way or up to the 7Ks and then back down, we want to make sure that VLAN 20 is forwarding end to end. Otherwise, we're not going to be able to actually send the layer 2 traffic between the devices. But if VLAN 10 is isolated just to a few of these devices on the access switch, VLAN 10 is also going to be running on the uplink between the FEX and the parent switch. Because again, like we talked about here yesterday, there's no spanning tree on these uplink ports. But once we actually get up to the end of row switch here, the 5K, we have this other instance of spanning tree for number 10 that we are going to be sending the BPDUs out all of these links. Because these links are spanning tree port type network. Anything that's running is a layer 2 interconnect. Now on the other side, if the 7K up here, the 7K up here, the 5K over here, if these do not have VLAN 10, it means that they are not going to be advertising spanning tree BPDUs for that particular VLAN number out the link. The end result is then going to be the 5K that actually does have that VLAN 10 used, it is automatically going to prune or basically stop forwarding VLAN 10 out the rest of these layer 2 segments. So it's a nice feature to have in there automatically. It basically means it automatically constrains your layer 2 forwarding, that there's really nothing else that you have to configure. Just you set the spanning tree port type to network, bridge assurance is going to be on, and it automatically prunes the VLANs to only the individual links that are actually needing it. Now at a later point in time, if we were to actually use VLAN 10 on a different portion of the network, it means that those switches will start to send the spanning tree BPDUs. Eventually, bridge assurance is going to unblock the link, and then we would be able to do our normal forwarding there. So the key here with this feature is that it is enabled globally by default, the spanning tree bridge assurance, but it's not actually enabled on the interface level until we set the link to run as the spanning tree port type network.